In this video, I'm going to show you how to do conversion from base 10 or decimal numbers into base 2 or binary numbers. There are a couple of different methods for doing this by hand. The method I'm going to show you is the repeated divide by 2 method. I think the easiest way to show how to do this repeated divide by 2 method is just to go with an example. And so here I'm going to convert 45 base 10 into binary form. And with the repeated divide by 2 method, this is the way that I like to set it up. So I take my number and I divide it by 2. And now what I'm going to create over here are two different columns. The first column is going to have the whole number part of this division, and the second part of the second column is going to have the remainder of this division. And just as a refresher to remind you what I mean by the remainder, just going back to doing long division, I'm doing 2 divided by 45. So 2 into 4 is 2, 2 times 2 is 4, 0, bring down the 5, 2 into 5 also goes 2 times 2 is 4, 1. 1 is the leftover from 5 minus 4. And so now that I've reached the end of the whole number part, what I'm left over with here is the 1, and so what I have is the 1 is the remainder. And the nice thing about dividing by 2 is that you're going to either have a remainder of 0 if the number is an even number, or 1 if the number is an odd number. So 45 divided by 2 is going to give me 22 with a remainder of 1. And then the reason that it's called repeated divide by 2 is I'm going to take that whole number part that I've just calculated, the result of that previous division, and I'm going to divide that by 2. So 22 divided by 2 is going to give me an 11 with a remainder of 0. Bring the whole number part down. 11 divided by 2 is 5 with a remainder of 1. Bring the whole number part down again. 5 divided by 2 is 2 with a remainder of 1. 2 divided by 2 is 1 with a remainder of 0. And finally, 1 divided by 2 is equal to 0 with a remainder of 1. So this repeated divide by 2 is I keep dividing the result of the previous operation by 2 until my whole number part that I've got left is 0. And then once that is complete, my answer, or my binary equivalent of the decimal number I was trying to convert, is created by building the number back up from the remainder parts, from the bottom to the top, with the bottom being the most significant bit and the top being the least significant bit. So the answer of converting 45 into binary is going to be 10 1101. So 45 base 10 is equal to 101101 base 2. Now, as a check, I can convert this binary back into decimal form to see if I've done everything correctly. So I can do the sum of the weights here to convert from the binary back into decimal. So this will be equal to 2 to the 0 plus 0 plus this column here is 2 squared plus 2 to the 3rd, 2 to the 4th is 0 plus 2 to the 5th. So this is 32 plus 8 plus 4 plus 1, which is equal to 45. So I did the conversion correctly. All right, let's do another conversion. This time I'm going to convert 321 into binary. So there's the number I'm trying to convert, 321, and then I'm going to do the repeated divide by 2. So divide 321 by 2. That's going to give me 160. So my result I'll write in one column, and the remainder I will write in a second column. And 160, and in this case the remainder is going to be 1. So now I need to divide 160 by 2. 160 divided by 2 is 80 with a remainder of 0. Bring the 80 down and divide it by 2. 80 divided by 2 is 40, also with a remainder of 0. And then 40 divided by 2, which is 20, with a remainder of 0. 20 over 2 is 10, with a remainder of 0. Bring the 10 down. 10 divided by 2 is 5 with a remainder of 0. And then 5 divided by 2 is 2 with a remainder of 1. 2 divided by 2 is 1 with a remainder of 0. And then 1 divided by 2 is 0 with a remainder of 1. And now that I've got my whole number part down to 0, I'm finished, and now I can build my number back up from the most significant bit at the bottom to the least significant bit here at the top. So 321 in base 10 is equal to 101 0 0 0 0 0, so 5 zeros, and then a 1. And once again I can do a check to make sure I did this conversion correctly, and looking at converting this base 2 number back into the base 10 number. So this is the 2 to the 0 column, and then 1, 2, 3, 4, 5, 6, 2 to the 6th column, 7, 8 to the 8th column. So this is going to be equal to 2 to the 8th plus 2 to the 6th plus 2 to the 0, which is 256 plus 64 plus 1, which is equal to 321. So yes, I did the conversion correctly. And this conversion method can be used for any whole decimal number. Doesn't matter the size, it's just if it's a really big number, you're going to have to do a lot of dividing by 2. So I hope you learned a little bit in this video, and I'll see you in the next one.